Welcome to the last half of section 7-8. We're going to do example B here online tonight. I ran out of time in class today, so go ahead and give this a shot. We're going to work through example B together, and then we'll talk about it tomorrow morning in class. So they want us to find the roots of this polynomial equation, 3x cubed plus 5x squared minus 15x minus 25. I went ahead and graphed this function in my calculator, and you can see here it's very difficult to use the calculator to find the roots sometimes because that one's just a hair above 2, this one's slightly above negative 2, and this one's slightly below negative 2. So the procedure where we go to find some of the roots using the calculator is going to fail here, because when we go to do the x minus r1 and the x minus r2 and the x minus r3, what we find is they're not whole numbers. They're not nice numbers to work with. They appear to be decimals. I do have a feeling that there are 1, 2, 3 roots, and we have a third degree equation. I can see the 3 roots, one there, and one there. So I think we're just going to have these 3 real roots to this equation. But again, they're not that easy to find. So what we do is we incorporate this thing called the rational root theorem. Let's take a look at this. It says, if you have this equation, it has rational roots in this form, p over q, where p is a factor of the constant term and q is a factor of the leading coefficient. Well, let's break that down. Let's talk about the constant term. And the constant term here is 25. I know it's negative 25, but let's just consider 25 just to make it simple. Well, the factors of 25 are plus or minus 1, plus or minus 5, and plus or minus 25. Okay? All of these are potential p's, which are factors of the constant term. So p could be any of these 6 numbers: positive negative 1, positive negative 5, positive negative 25. Let's also take a look at the leading coefficient. And the leading coefficient here in this problem is 3 because of the 3x cubed. Coefficient. Sorry about that. The leading coefficient, and what we have here is 3. So we need to list out the factors of 3. Positive or negative 1, positive or negative 3. So what we find according to the rational root theorem is the potential roots of this function will be in the form p over q, where p are would be the blue numbers, p would be made up of the blue numbers, and q would be made up of the red numbers. So what we have here for the potential solutions to this problem, first of all, positive negative 1, positive negative 5, positive negative 25 are all potential solutions, because if you do p divided by q, since a potential q is 1, all right, since 1 is one of the potential q's, then our potential p over q's will be 1 over 1, 5 over 1, and 25 over 1. So a listing of the potential p's would actually automatically give you a listing of the potential solutions. So these are potential solutions to this problem. The other ones are going to be given by a mixture of positive or negative 1 over 3, so plus or minus 1/3. You do p over q, the potential p's over the q's. We don't have to do, I listed these already with the 1 over 1, 5 over 1, 25 over 1. They're right here in blue. But when you put them over the q's, that could be 3, you have 1/3, 5/3, and 25/3. These are all the potential solutions or rational roots of this polynomial. So let's take a look at the graph and let's think about which of those roots are really possibilities when you look up here. I think we can automatically cross out the blue ones, because this graph, which goes up slightly below negative 2, down slightly above negative 2, and then back up slightly larger than negative 2, well, that's going to automatically rule out positive or negative 1. That's clearly not a root. Positive or negative 5, way off the screen, shouldn't be included. Positive, negative 25, not included as well. Let's take a look at the next one. Positive or negative 1/3. Well, for positive or negative 1/3 to be a potential solution, the graph would have to cross here or there. And you can see clearly that this graph does not. So we're going to eliminate that. What about positive or negative 25/3? Positive or negative 25/3, that's like positive 8.3 repeating and negative 8.3 repeating. Graph clearly does not cross anywhere near positive 8 or negative 8. So that's going to be out as well. Finally, let's consider positive or negative 5/3. If we think about 5/3, let's take 3 into 5. That's 1 with the remainder of 2, so it's 1 2/3. Is it realistic to think that this graph could potentially cross at either positive 1 2/3? I don't think so. Negative 1 2/3? Maybe. Finally, we have a potential solution of negative 5/3. So I'm thinking that that's a good possibility for us to use in this problem. So I think that a potential solution is going to be at negative, I think, let's call these R1, R2, and R3. So I think that R2 could possibly be negative 5/3. If that's the case, let's think about what x minus R2 would look like if we're putting this polynomial in factored form. Well, if it were in factored form, this set of parentheses would be x plus 5/3. So here's what we do at this point. We've pinpointed what we think is a logical root to this polynomial. So let's take this x plus 5/3 and use it as our divisor. Let's take the original equation at the top of the screen and use it as our dividend. So we're going to take x plus 5/3 and divide it into x cubed plus 5x squared minus 15x minus 25. Feel free to post any questions that come up as you're watching this video. Again, any questions that you ask, kick right to my cell phone, and I can answer them as soon as I get them. So let's take a look and try dividing this. Now, when you're doing long division with polynomials, you want to think about x times what will give me 3x cubed. X times 3x squared. X times 3x squared will give me 3x cubed. We need to distribute that 3x squared here and here. What's 3x squared times 5/3? Let's think about that. The 3's would cancel. I think we get positive 5x squared. Put a line under it and subtract this entire quantity. So at this point, the 3x cubeds cancel, the 5x squareds cancel, and we're going to bring down the remaining portions of the dividend. Negative 15x minus 25. I'm going to get rid of these arcs because they're not going to be in use for the next part of what I'm about to do. Let's switch to blue and think about how many times does x go into negative 15x, or better yet, what number would you multiply by x to produce negative 15x? And that answer is negative 15. So now the negative 15 in blue is what we're going to distribute to the divisor and see what we get down in here. Okay? So we get negative 15 times x, negative 15x. Check this out. Negative 15 times 5/3. 3 goes into 15 5 times. 5 times 5. Go ahead, if you don't understand it, write it out. 5/3 times negative 15 is negative 25. If I put a line under it and subtract this entire quantity, they cancel, and my remainder is 0, which makes me extremely happy, because I know that my original equation, 3x cubed plus 5x squared minus 15x minus 25, factors neatly into x plus 5 thirds times 3x squared minus 15. So this original, let's circle it here, let's highlight it. This was the original problem that we set equal to 0. We're going to set this equal to 0 and solve it. We know that what I just circled in green here factors into this times that. Okay? So if either of these equations, either of these factors was set equal to 0, x would either equal negative 5 thirds, which we already thought was a solution. Now let's set this equal to 0 and solve. We're going to add 15 to both sides. We're going to divide both sides by 3. We're going to square root both sides. Plus or minus root 5. That's going to give me the other two solutions to this equation. So we have 3 roots, one at negative 5 thirds, and 2, one being at positive root 5, the other being at negative root 5. If you check that on your calculator, positive and negative root 5, probably 2 point something, and negative 2 point something. So we have all 3 roots of this polynomial equation. Negative 5 thirds, positive root 5, and negative root 5. Again, any questions, let me know. And we will recap that quickly tomorrow before we get to synthetic division, the last piece of the 7-8 puzzle.